Welcome to Logic Circuit lesson for Secondary 2. At the end of this lesson, learners should be able to define logic circuits. Learners should be able to define logic gates, identify types of logic gates, explain and or and not gates, draw truth tables, and state uses of logic gates. By way of introduction, we will be looking at logic circuits. We'll be looking at switching circuits that make up the logic gates, and as they relate to logical operations concerning data. What is a logic gate? A logic gate is a physical device implementing a Boolean function. That is, it performs logical operation on one or more inputs and outputs. Logic gates are building blocks of digital circuits. They have two inputs and give out one output. Logic gates are also electronic gates that require power supply. Gate inputs are driven by voltages having two nominal values of 0 and 5 volts. They represent 0 and 1 respectively. 0 is low, 1 is high. Now, concerning the output, it's either 0 or 5 volts. In general, zeros or 1 are the outputs. Now, what are the types of logic gates? There are 7 types of logic gates. The AND, the OR, the NOT gate. Others include the NAND gate, the NOR gate, the XOR gate, and the XNOR gate. We'll look at the AND, OR, and NOT gates specifically. The AND gate. It's an electronic circuit that gives a high output of 1. A high output of 1 when all of the inputs are high. When all inputs are high. It's represented by a dot, as in A dot B. Sometimes you can remove the dot to just have AB. That's the AND gate. The AND gate symbol is shown. 2 inputs, 1 output. Input A and B. Like 1 times 1 will give 1. Input 1 times input 0 will give an output of 0. Input 0 times input 0 will give an output of 0. How about the OR gate? The OR gate is a logic electronic circuit gate that will give you a high output of 1 when one or more of its inputs are high. And the symbol is as shown. 2 inputs will give an output of A plus B. A plus B high output. 0 plus 1 will give you 1. It could be A that is high and B that is low. 1 plus 0 will give you 1. Both inputs could be high. A and B high. 1 plus 1 will give you 1. Remember that 1 plus 1 is 1 in base 2. 1 plus 1 is 1 in base 2. And 0 plus 0 will give you 0. The NOT gate. The NOT gate is the third gate referred to as an inverter. Is referred to as an inverter. The input comes out as inverted of the output. Inverted output. So if you have an input variable like A, an input variable like A will give an output of not A. Not A is written also like this, or A with a bar above it. And the symbol is this. Take note of the bubble. Input A giving output of A bar. The equation for a NOT gate is such that the Boolean equation that represents NOT gate is x is equal to A bar. Well, we'll stop this lesson here and continue in track 2 with truth table and uses of logic gate. Thank you.